so molecular formulas are very similar to empirical formulas, but we might define molecular formulas as the actual ratio of molecules in a compound. Of elements in a compound. So empirical is the lowest whole number ratio, right? And the actual ratio of elements in a compound sometimes is the same as the empirical formula, but sometimes it can be different as well. So I think the example I gave earlier on the empirical formula one was C6H12O6. So this is a molecular formula, alright? That is, there's a compound that has exactly 6 C's, exactly 12 O's, or H's, and exactly 6 O's. Is this an empirical formula? It is not, because we can divide all those numbers by 2, and the empirical formula becomes this, okay? So molecular is the actual number, empirical is the lowest whole number. Sometimes a molecular formula can also be the empirical, but if it's divisible or simplifiable, then then they're different things. All right. So in order to solve these problems, the first step is really the same as empirical. So same steps as empirical formula. And the thing that's going to be different is the problem, or I, will have to give you a molar mass. All right. Given the molar mass, of the molecule, determine the factor of the empirical formula, or the empirical formula's molar mass, okay, or the empirical mass to molar mass. Alright, you're going to see how this works in just a second. So our example for this one is going to be, let's say you have something, a compound that weighs, it's 1.52 grams of nitrogen, and it's 3.47 grams of oxygen. And then we know by some kind of experimentation, it would be a mass spectrometer, which we're not going to go into, you know the molar mass is approximately 90 to 95 grams per mole. So this would be the number that we would get from the periodic table. Okay? So you're given that information, and you're asked to find what is the molecular formula. Alright? So if we go back to our steps in empirical formula, our first step is, if we're given percentages, change them to mass. We're already given masses. Alright? So the second step is change masses to moles. So I'm going to change both of my masses to moles. So nitrogen, we're going to have grams of nitrogen on the bottom, and the molar mass of nitrogen is 14.007, and it's per 1 mole. On the bottom, oxygen is 15.999 grams per mole. So when we do this math, for nitrogen, we're going to get 0.108 moles. And for oxygen, we're going to get 0.217 moles. Okay? So from that, our next step is divide by our smallest mole amount. So it is obviously 0.108. So we're going to divide both of these by 0.108, and hopefully get a whole number ratio. 0.108. So this comes out to 2, and this comes out to 1. So because of that, our empirical formula then is NO2. Alright? So that is our empirical. We can't simplify a 1:2 ratio any smaller. So now what we're going to do for molecular formula is we want to find the molar mass of this. So if I have 1 nitrogen, I'm going to have 1 times 14.007 plus 2 times 15.999. And when we add that up, we're going to get 46.005 grams per mole. Okay? So really we want to find out how many times does 46 go into this 90 to 95-ish grams per mole. Alright, so we're really just going to put 46 in the denominator and get an approximation. So how many times does 46 go into 90 to 95-ish? It goes in approximately 2 times. So all that says is that my molecular mass must be twice as big as my empirical formula. So what that means is, my empirical formula, I really need 2 of everything. So it's going to become N2O4, okay? Because this thing is going to be twice as heavy as NO2, because I'm going to have 2 times 14.07 plus 4 times 15.999. But I still, what's a 2 to 4 ratio? It's a 1 to 2 ratio. Alright, so its empirical formula is NO2, but I want the molecular formula. If it weighs somewhere between 90 and 95 grams per mole, it can't be my empirical, but it must be N2O4. So anyways, really similar to empirical formula, just a step at the end. I will have to give you the molar mass. You just need to find out how much bigger is the molar mass than the empirical formula's molar mass. And then whatever that factor is, multiply all of your subscripts by that factor.